So welcome to another segment of my chemistry videos as we look at preparation of ammonia, but we are going to start with laboratory preparation of ammonia. So if you want to prepare ammonia in the laboratory, it's very simple. You just need to react an alkali with any ammonium compound. So remember, an alkali is a base that is soluble. React it with any ammonium compound, but of course you need to heat the mixture that is going to produce ammonia in the laboratory. For example, you can react a base we are calling as being calcium hydroxide. This is in aqueous, reacting with what we are calling as being ammonium chloride, and this ammonium chloride is in aqueous. So the moment you treat in the presence of heat, you are going to produce what we are calling as being calcium chloride. Ammonia is going to be produced, but again you're going to find that H2O is also going to be produced, which is in liquid form, that is in gaseous form, and that is going to be in aqueous form. So remember, you need to write a balanced one. You can put up a 2 there. It simply means that you can put up a 2 there. So when you put up a 2 there, you can also put up a 2 there. Then the equation becomes balanced. So that is what we mean. So we are going to produce a salt, but our interest is the ammonia that is produced. So remember that ammonia is the only alkaline gas. I want to mention that ammonia is the only alkaline gas that is able to change a red litmus paper to blue. So this is what you can do. Now the apparatus that you can use is what I have already drawn for you this side. So this is the type of apparatus that you can use in the laboratory preparation. So we do have, let's label a few things there. So we do have this one as being our gas jar. Then we do have a solution inside. This time we are not using water, so what we are going to use there is calcium oxide. So this is a calcium oxide tower. So you have got a calcium oxide tower. This is the arrangement. So it's a calcium oxide tower. Why? Because inside there's actually calcium oxide. All right. So it's a calcium oxide tower, but inside it there's calcium. You can see I've dotted it in red. Okay. So then in this case we also have a test tube. So this can represent a test tube. This, as usual, is representing our delivery tube, delivering the gas into this calcium oxide tower. Then there, you do have a mixture. So that is a mixture of, calcium hydroxide. So that is a mixture of calcium hydroxide, plus, ammonium chloride. Remember the one that I used in the equation? So this is the ammonium chloride that you have. And that mixture needs to be subjected to what we are calling as being heat. So once you heat, ammonia will be produced, and this ammonia will travel to start forming bubbles, and hence it is going to be collected. So the gas that you're going to have this side, that gas is going to be ammonia gas. So that is what you are going to have. So that is going to be ammonia. Now the question that you may have, what is the purpose of the calcium oxide? Remember, calcium oxide, acts as a drying agent. So it's a drying agent for ammonia because water is produced in this process. So the water, the gas that is produced needs to be dried, and hence you bubble it through calcium oxide. We do not use water because water can easily react with what we are calling as being ammonia gas. So that is what you need to remember. At the same time, a few things that you need to remember is that the test tube, when you look at the test tube is tilted. So the test tube is actually tilted. Now what is the reason why the test tube is tilted? Tilted slightly downwards, as you can see there. But the reason is very simple. We want to prevent water that is formed from this reaction from running back into the reaction mixture, which may boil and cause an explosion. So we do not want the water to run back into the reaction mixture, boil, and later on cause an explosion. No wonder the test tube is actually tilted. So another thing that you need to know, what is the method of collection? What is the method of collecting this gas? What do we call that method? Of course, that method is what we can simply call as being the downward. So we can say it is the downward displacement of air. So remember, the gas will settle there, the air will be pushed there. So we are calling it downward displacement of air. And why do we use downward displacement of air? So the reason why we use this one, it is because it is less dense. Ammonia, in this case NH3, is less dense. Yeah, so it is less dense than air. So that is why we use such an arrangement. Right, let's try to put up a few concepts there. Some other concept that you need to remember is that what is the drying agent that we use when we are preparing? So the drying agent that we use when we are preparing ammonia, like I said, it is simply calcium oxide, what we simply call as being quicklime. So that is what we are going to be using. Like I said, there could be other drying agents like calcium chloride. You can also use maybe calcium chloride, but they are not good. When you look at drying agents like calcium chloride and also maybe concentrated sulfuric acid, these normally we do not use them. What is the reason? It is because they can easily react with what we are calling as being the ammonia. Okay, quickly I can talk about maybe some of the physical properties. So I can talk about physical properties of ammonia. So what are some of the physical properties of ammonia that you need to remember? Well, some of them that we can talk about, it is less dense than air. So ammonia is less dense than air. Two, you can say it is very soluble in water. So it is capable of dissolving in water. Then three, it is a colorless, so we can say that it is a colorless gas. Then four, we can say that it has a pungent, so it has a pungent choking smell. So you can go on choking if you inhale ammonia. Very dangerous. Okay, what about in terms of what we are calling as being the chemical properties? What are some of the chemical properties of ammonia that you need to remember? Like I said, ammonia is the only alkaline gas. Therefore, it turns, red litmus. We can say that it turns red litmus paper blue. So it's the only alkaline gas that is capable of turning red litmus paper to blue. Another property, chemical, you need to remember is that it dissolves in water. It dissolves in water to form up ammonium hydroxide. We can write that reaction. So when ammonia NH3, which is in gaseous form, reacts with H2O in liquid form, it produces what we are calling as being ammonium hydroxide, that is still in aqueous. No wonder ammonia cannot be passed through water, because it will dissolve to form up ammonium chloride. Another chemical property that we can talk about there, let it be the fourth one. Let's say, is it the fourth one or the third one? The third one there. I can simply tell you that ammonia, you need to understand that ammonia reacts with hydrogen. So ammonia is also capable of reacting with hydrogen chloride. Hydrogen chloride, to form a white smoke. So that white smoke that is formed is what we call ammonium chloride. So in other words, when you have NH3, which is in gaseous form reacting with hydrogen chloride, which is also in gaseous form, that is going to produce ammonium chloride, which is in solid form. So that is the overall reaction that you need to remember. So basically, in my next discussion, we are going to talk about now the industrial way of preparing ammonia, which is called the Haber process. Thank you so much for watching. See you in my next video.